In the previous video, I told you that real numbers has decimal expansions. Now that decimal expansions, we are going to represent it in number line. That is representing real numbers on the number line. Okay. To maximum any number of decimal places we can represent. Now I will show you to represent few set of decimal numbers on the number line. First, if we take 3.5, this can be easily represented on the number line. It is 0, 1, 2, 3, 4. 3.5 will be here. This middle point will be 3.5. So like this we have learnt in our lower classes to represent this. Now if we have 2 or 3 numbers in the decimal place, how we will represent it? So we will magnify those number lines, then we will represent that numbers on the number line. So now we are going to visualize 3.4632 on a number line. You know to represent till one decimal place. Now here 4 decimal places are there. So we will enlarge the numbers step by step, then we will do. Okay. So first 3. So you know to represent number 3 on the number line. That is, if you take 1, 2, 3, 4. 3.4 also you can able to do in this line itself. So after this 3, first point is 3.1. Then 3.2, 3.3, 3.4. So this point is 3.4. This is the first point, 3.4. Then the next one is 3.46. So that will be between 3.4 and 3.5. That will be between 3.4 and 3.5. So that part alone I will enlarge now. Okay, so that part alone I will enlarge now. So the first point is 3.4. That is 3.40. You can write this as 3.40. Then the last point is 3.50. Okay, so in between this, you divide it into 10 equal parts. So this is 3.41, 3.40 first one, 3.41, 3.42, 3.43, 3.44, 3.45, 3.46, 3.47, then 3.48, 3.49 and the last point is 3.50. So the next point is 3.46. So where is 3.46? Here is our 3.46. But this number also they didn't ask you to represent. So 3.463. So that will be between 3.46 and 3.47. Okay, so enlarge this like this. So the first one is you draw a number line. Simple way to represent. So this one is 3.460. Okay, then next point is 3.461. Then next point is 3.462. Next point is 3.463. Like this you have to continue. And the last point is 3.470. So 463, then 3.464, 3.465. Like this it will be moved. 465, 466, 67, 68, 69, 70. Okay. So now this point is 3.463. 3.463. So this is our 3.463. Then the next one is, next decimal number is 3.4632. The meaning for this is that part alone we are enlarging, magnifying that and telling. So these many numbers, decimal numbers will be there inside that two decimal numbers. Okay. So here 3.463 and 3.464. In between this you have that point. Okay. 3.4630, 3.4631, 4.3632, then 33, 34, 35, 36, 37, 38, 39, 40. This will be the line. So what they are asking you to represent? 3.4632. So that number is here. 3.4632. So we have visualized this real number, this rational number, this decimal number on the given number line. So when you enlarge each and every part of this, these many numbers you have inside that. These many decimal expansions, decimal numbers you have in between two numbers. Okay, then like this, how much ever numbers they have given, you can magnify between the two numbers and you can represent that easily. Now I will tell you how to locate root 2 on the number line. Root 2 is an irrational number that we know. Previously I told you how to represent rational number on a number line. Now this one is root 2. This is an irrational number. This we are going to represent in the number line. When you take a small square, 1 centimeter square, 1 centimeter square. If you take like this, when you take a 1 centimeter square, so this one is 1 centimeter and this one is 1 centimeter. When you draw a diagonal for this square, when you draw a diagonal for this square, this one is you will get it as a right angle triangle. Okay, so when you get this as a right angle triangle, using Pythagoras theorem, you can say that sum of the squares of the other two sides, will be equal to the hypotenuse square. So this one is 1 squared plus 1 squared is 2. So this one will be, this length will be root 2. So this one will be root 2. So this part diagonal will be root 2. So the same thing, I will do it on the number line. On the number line, I will locate this. You take 0, 1, 2. This is the number line. Okay. So this one is the number line. The same thing I am doing it here. So this is 1 centimeter. So I am drawing a square of area 1 centimeter. 1 centimeter square I am drawing. As I explained you here, if I draw this diagonal, that length will be root 2. So this is 1 centimeter, this is 1 centimeter. So this length is root 2. But I was asked to locate root 2 on the number line. This root 2 length, this root 2 is here. So I'll take a compass, measure this length and measure this length in the compass, and if I cut it on the number line, that length of root 2 and the length on the number line will be equal. Okay, this is how. So this length, I don't know what is the length of root 2. So after drawing this, I can able to find this measurement as root 2. So length of this one is root 2. So I take a compass, measure this length, then I will cut that on the number line. So this will be the length of root 2. This is the length of root 2. So I have represented, I have located root 2 on the number line. So if you take this as D, OD is equal to root 2. So when you find the square root of this, what will be the square root of this? 1 point something you will get. So that definitely when you measure this, you will get this measurement as that one. Okay, so what is root 2? You know to find the square root of that. So that is 1 ones are 1, 1. Then 2. Then you take 2 numbers here, 2 zeros here. These things and all you know already. So 4. 4 fours are 16, 96. So 1 point. After that point only you will keep 2 zeros. So 1.41 something you will get. So that 1.41 definitely you will get this. So you can write this as approximately. That is not exact value. Approximately 1.4. It should not be exactly on 1.4. Slightly after that 1.1 you have to get. Little greater than that you have to get. So 1.41 centimeter. So this is the length OD. OD is approximately equal to 1.41. So I represented root 2 on the number line. So the same procedure you have to do for whatever root numbers they have asked. Now the same procedure we will follow to represent root 3 on the number line. Okay. So number line 0, 1, 2. So the same way 1 centimeter square. You know that this one is root 2. This measurement is root 2. Okay. You draw a perpendicular for this base. You draw a perpendicular, that is 90 degree. How we have drawn here? This is 1 centimeter. A perpendicular you have drawn, then you have joined this. The same procedure. So many times if you are doing accordingly, you will get the root values. Okay, so this one. So here first procedure is 1 centimeter extension. This one is also 1 centimeter. You will join this. You will get root 2. Here also the same thing. Perpendicular 1 centimeter. You will cut 1 centimeter on this line and you will join this. So what is the length of this? You calculate it. This is root 2. As usual, this is a right angle triangle. This one is root 2. This measurement is 1 centimeter. So root 2 the whole square is 2. Pythagoras theorem. So root 2 the whole square plus 1. What is root 2 the whole square? 2. 2 plus 1. Root 2 plus 1 is root 3. So which one is root 3? This line is root 3. So like this, if you are moving on and on with the same procedure, whatever root values are there, you can represent that number on the number line. So this one is root 3. You take the measurement in the compass, cut it here on the number line. Okay, same way you find the root value. Root 3. What is root 3? 1.7 something you will get. So that will be the measurement of. Definitely you will get that on this number line. So root 3 approximately equal to 1.7. This is how you will represent rational and irrational numbers on the number line. Both can be represented. Okay, understood?